Okay, problems 3 and 4. Problem 3, we've done a lot of problems like these. They're just given to us in a little different way, the little chart problem. We got these two grocery stores producing melons from J and K. From J, it's got a mean of 133, a standard deviation of 5. So they ask you to figure out what the probability of having a diameter greater than 137 was. So just normal CDF from 137 to infinity. That information, 21.18%. And then they just told me what that probability was from K. They just told me it was 84.13%. And then, so then these for melons that grow short, 70% come from J, 30% from K. So I just drew this little chart, 70% from J, 30% for K. For J, the probability of over 137 was at 21.18%, so that's that percent of that. And then for K, it's 84.13% of that number is 30, just everything else added up. And then if we pick a melon at random, what's the probability that it's greater than 137? So we're just adding this one and this one, so 40.065%. And then part C says, given that it's greater than 137, so that's that row, 40.065, what's the probability that it came from J? 14.826, 37%. Question number 4. I kind of like this question. I thought it was pretty cool. I know you're going to have to kind of follow along with the picture, but we got these chemicals, X, Y, and Z at 3 different sites, and the distribution after studying of these chemicals. So the first one says for chemical Z, which is the third chemical. No, it's hard to see, sorry. Describe similar and how they're different. So I just said they all have about the same median. If you look, the middle is about the same. It's kind of right between the 6 and 8 on all of them, so somewhere in the neighborhood of 7. They're all roughly normal. There's no skewness in those 3. The big difference is the spread. So you got to mention the spread. This one's a really tiny spread out, really small interquartile range compared to this one, and then that one. So site 3 is the most spread out. Site 1 is the least spread out. Now we want to study these things and figure out where they came from, right? So we have this piece of pottery, but we don't know where it came from. And we took an analysis, and we found out that X plus Y plus Z equals 20.5%. Where did it come from? So I looked at this 2 different ways. I think they're both okay. You can average the median. So if you average the medians for X, just add up, this one plus this one plus this one. You get, site 1, sorry, did that backwards. So site 1 medians, this one plus this one plus this one would be 27. Site 2 gave me a 16, site 3 gave me a 20. So adding up X, Y, and Z, I got 20.5. So it's likely there. But that's not really the best way, because it could have been anything. This is a much better gauge. If you take the smallest value for X on all 3, so X, Y, and Z, so you add up the smallest and then you add up the biggest, you can get the ranges, right? So in site 1, it's got to be somewhere between 21 and 33. So adding up the smallest numbers and adding up the biggest numbers. Site 2 is between 13 and 19, and site 3 it's between 14 and 26. So it's 20.5. Can't be there, just doesn't fit. Even if you add up all of the smallest things, you get 21, so it's not going to be there. Same thing there. If you add up the biggest, you only get 19, it's not going to be there. So most likely it came from site 3. And then the last question says, if we don't know where it came from, we can only look at one chemical X, Y, or Z, which one should we use? And if you look at the distributions, I picked Y, and the reason you picked Y is because there's no overlap in the distribution. So if you look at the center ones, the first Y is way up here, second Y is way down here, the third Y is right in the middle. So if you pick something from Y and got a number like 13, it has to be from this one. It's not going to fit in those other ones all. So I just said chemical Y because there's no overlap in the distributions.